Sayın Dekanım, değerli katılımcılar, değerli öğretim görevlisi, öğretim üyesi arkadaşlarım. Bugünkü konuğumuz doçent doktor Anna Haydar. Kendisi hakkında biraz bilgi vereceğim. Beyrut Amerikan Üniversitesi lisans ve öğretmenlik derecelerini Kolombiya Üniversitesi Öğretmenler Koleji'nde matematik eğitimi alanında yüksek lisans ve doktora derecelerini almıştır. New York Şehit Üniversitesi Brooklyn College'de çocukluk dönemi matematik eğitimi programında öğretim üyesi ve aynı zamanda lisansüstü düzeyde matematik eğitimi ve araştırma üzerine dersler vermektedir. Haydar aynı zamanda New York Üniversitesi Mezun Merkezi'nde kentsel eğitim programları doktoralı öğretim üyesi olarak görev yapmaktadır. Daha önce Rand Eğitim ve Dahor Kator'da Yüksek Eğitim Konseyi'nde müfredat standartları mesleki gelişim danışmanlığı yapmıştır. Haydar'ın araştırma ilgi alanları ve yayınları eğitim politikası, göreve yeni başlayan matematik öğretmenleri, kaynaştırma, bütünleştirme, ders imecesi ve öğretmenleri klinik kullanımları üzerine odaklanmaktadır. Metromat, The Center for Mathematics American Cities, Amerika Şehirler Arası Matematik Merkezi'nde birçok araştırma yürütmüştür. Uluslararası deneyimi Orta Doğu, Avrupa ve Amerika araştırmaları, çalışmaları ve danışmanlıklarını kapsamaktadır. Haydar, Umman Eğitim Bakanlığı'nda ve Ürdün'deki okullarda müfredat standartlarını geliştirme ve matematik eğitimini iyileştirme projeleri konusunda da danışmanlık yapmıştır. Halen Teachers to Teachers Global hem Ekvator'da hem de Guatemala'daki matematik öğretmenleriyle işbirliği çalışmalarını devam etmektedir. Doçent Doktor Anna Haydar, TÜBİTAK 2021 konuk ve akademik izinli bilim insanı destekleme programı kapsamında Türkiye'ye gelmiştir ve eğitim fakültelerinde 6 ay süreyle ziyaretçi araştırmacı olarak akademik çalışmalarını sürdürmektedir. Kendisini buraya davet ediyoruz.
Thank you very much for this introduction, and thank you all for being here. I know it's the end of the semester and the weather and the holiday, so I really appreciate your presence here.
Herkese teşekkür ediyorum. Burada olmaktan çok mutluyum. Sömestrın son dönemi, hava da çok sıcak. Ama burada olmak oldukça güzel.
So I'll be talking with you about presenting meaningful mathematical tasks for stories from history of mathematics and
Sunumum matematik eğitimi ve tarih. Matematik tarihinde hikayeler araçlarıyla anlamlı matematik üzerine olacak. Sunumun Türkçesi ve İngilizcesi olduğu için herhangi bir şey yapmayacağım ama önemli olan yerleri çevirmeye çalışacağız.
Before I explain more like what exactly I wanna discuss in my talk, just wanna to put context to when I am not in Turkey. I'm usually in New York City. This is my campus, Brooklyn College, and I work with graduate students who want to become childhood mathematics educators, and we mainly deal with the question of how to make mathematics more accessible and meaningful for young kids.
Burada New York Üniversitesi'nde görüyorsunuz matematik eğitimindeki öğrencileri lisans düzeyindeki matematik çocukluk döneminde matematik eğitimi konusunda eğitimler vermekteyim. Gördüğünüzde benim New York Üniversitesi'ndeki fotoğraflar.
So from the title, there are three themes that I would like to address during this talk. You can see mathematical tasks. You can see also stories and the use of history. So the questions really become, why all the attention on mathematical tasks? And then why do we use storytelling in teaching elementary mathematics? And why now we're adding also to draw on stories from history of mathematics? So this will be the three main themes of my talk.
3 tane amacım var. Tahtada gördüğünüz gibi sunumda da belirttiği çevirileri yapılan hikayeler aracılığıyla anlamlı matematiksel görevler sunmak, tüm dikkatleri neden matematiksel görevler veriliyor ve ilk öğretimde matematik öğretiminde neden hikaye anlatımlarını kullanmalıyız? Neden matematik tarihinde hikayeler kullanmak önemlidir?
So let's start with the first theme, which is the rich mathematical task. And I want to just prove to you, or like agree with you, or try to convince you that not all tasks are created equal. Alright, let's take an example. So,
Bir örnek vermek istiyorum. Sunumda gördüğünüz gibi.
so this is a very simple addition fact.
Bu çok basit bir soru ama
What is 8 plus 9?
8 artı 9 nedir?
And right, I mean, at the elementary, we do want our kids to be able to do such fact. Now, just notice the task. If I just ask a child, what is 8 plus 9, and then they give me the answer 17.
Eğer çocuklara sorduğunuzda mutlaka size şu cevabı vereceklerdir. 8 artı 9 nedir? 17.
That's different than I add a follow up and say, convince me that 9 plus 8 equals 17.
Eğer bunun yerini değiştirsem 9 artı 8 nedir diye sorarsam gene 17 diyeceklerdir.
In the second task, this addition of convince me will force the child to think about the strategies on how they really can.
Aslında ikinci sorduğum şey biraz da şey diyor, düşündürmeye yönelik. Yani bir strateji geliştirme adına değiştirdiğinizde onların düşüncelerini de değiştirirsiniz.
So we're pushing them to say more than just the answer is 17, and maybe think about different ways of coming to the answer 17. Like for example, right, we can see that 8 plus 9, if I take 1 from the 8 and I add it to the 9, now I have 10 plus 7. Another way, they can decompose the 8 into 7 and 1, and this way I have 7 plus 10. Or some kids are good with doubles, so they might see that 9 plus 9 is 18 minus 1, or 8 plus 8 is 16 plus 1, so on.
Sonunda da belirtildiği gibi çocuk 17'yi ezbere bilebilir ama 10 artı 7 deyince ekler, 8'den çıkartır. 7 artı 1 artı 9 eksi 8 dediğinde de yine parçalar, ekler, 2 katını yapar veya yuvarlar. Bu şekilde biz onların düşüncelerini değiştiririz veya düşüncelerini değişmesini sağlayabiliriz.
So this text, even though they are very similar, but at the same time they're very different in what they demand the child to do and to think about.
Böylece düşünmelerini sağlamış oluruz.
Alright, let's take another example now, like go to, for multiplication. If I ask you to do 24 multiplied by 5 in your head, I don't want you to write the algorithm.
Şimdi bu şey diyor, 24 çarpı 5'i zihinsel olarak çözmeye çalış. I'm taking that to 1/10. I can use right.
First, try to do it in your head without writing.
Okay. Who will say? You asked.
Do we have answers?
Cevabınız var mı?
120.
It's very easy question, our students.
Right?
He said 120.
Did we all get 120?
Yes.
Okay. Obviously, it is the correct answer. But let's see if we can get two different ways of getting to that answer.
Bu soruyu başka bir türlü nasıl sorabiliriz? Ya da nasıl cevap verebiliriz?
Who can tell us about their strategy? How did you get the 120?
20 times 5 and 4 times 5.
Alright, so usually you split, right, the 24 into the 20s and the 4, and then you distributed the multiplication. Very nice. Anybody use another?
Başka fikri olan var mı? Böyle kullanabilecek.
60 times 2.
60 times 2.
How did you get to the 60?
Şey diyor, 60'ı nasıl buldun diyor.
60 çarpı 2 demek istedim.
Ha, he 60 plus 5 2. Is it possible?
All right, yeah, so for
Farklı.
that, 24 is 2 times 12, and 12 times 5 is 60, so 2 times, beautiful, yeah.
Evet,
Absolutely.
iyi diyor, güzel.
Multiply 10, then divide 2.
Okay, so you multiply it by 10, because 5 is half of 10, and then you multiply by 2. You see already, we're talking about different strategies, and some
Biraz
of them
biz diyor farklı stratejileri konuşuyoruz. Biraz daha düşünürsek çok güzel.
Now my follow-up will be like to make this task even more interesting and higher level. I'll ask you to draw your strategies. Well, we don't have time to do that, but some of the drawings, right, it's like represent exactly that strategy that you said.
Ya birçok zaten stratejiyi siz de söylediniz.
So you see, like the yellow one is like your strategy.
Mesela sarı olan sizin stratejiniz dedi.
Right, multiply here by 10 and then divide it by 2, and you can see it like
Evet,
that.
sizin sarı olan sizin stratejinizi gösteriyor, sizin dediğiniz.
And then your first strategy, here it is right in the
Mesela ilk söylenen de
that's 5
sizinki
and
diyor.
4. Okay, so again, right, I mean, if I ask 24 times 5 and just I need the answer, this is a task. If I add those, like, okay, what's your strategy, and I add either another dimension, draw your thinking, draw your strategy, already the task is like really more higher, right? Would you agree that it is really higher level? Okay, I'm gonna skip this. Taking this into consideration now, let's vote. I mean, I want to ask you, like, which one of those two tasks are higher level? Is it this or that? You can read it here.
Buradan okuyun. Türkçe okuyarak çekiliyorum.
Those of you, I'm gonna give you a few seconds just to read it, and then we'll report.
Yes, we read.
All right. So
What will you do?
now my question is like, all right, let's vote. Who think that this, the first one, is a higher level than the second one? You can raise your hands. Who think that the first one is higher? Who think that you think the first one?
I think the second one is more idle because it's make way to the people to more complicated way. So they can think differently, I guess.
Right, absolutely. So did you all vote that the second one is a higher level?
Yes.
Right.
İkinci çok daha yüksek bir düzeyde mi diyor ikinci
And
bölüm.
exactly because of what you said, right? It's like more open-ended. There are different scenarios that the child needs to think about. So in terms of thinking, it's definitely higher level than the other one. The other one
Farklı
just
senaryolar verdiğinizde çocukları daha çok düşündürmeyi sağlarsınız. Yani ikinci biraz daha karmaşık bir yapı olsa da düşünce açısından farklı düşünmelerini sağlarlar.
Alright. Also because of time, this is another example.
Ya bu da buna benzer başka bir örnek.
Again, you will see if you had more time and you look at it, the second one is more, it's a higher level.
Ve ikincisi daha yüksek seviyede. Şimdi okuyup tekrar bakabilirseniz sorulara.
Because it's open to various scenarios and like.
Bunlar da senaryolar baktığımızda.
So, why we gave all this example? To what we know now in the math education community, well, not all tasks are created equal. And different tasks will provoke different levels and kind of student thinking. You can read this right in here, in the yellow. Now I'm moving to the blue one. So the level and kind of thinking in which students engage determines what they will learn. So that's why really it's very important whenever I'm giving the child a task to think of the possibility of what they will learn in terms of what they will be engaged with. There's one particular type of task that are very powerful, especially at the elementary school, and now we find more examples of. We call them low floor, high ceiling tasks, which they allow students to show what they can do rather than what they cannot. And we call them low floor because it allows everyone to access. So they have like really entry point to everyone to access the task. But then, depends on your level, you can go to different levels of sophistication. Yeah?
It's clear that.
Okay. All right, so if anything is not clear, please feel free to just ask or not interrupt me. And
Eğer
then
anlamlarsanız beni durdurun ve soru sorabilirsiniz diyor. Yani beni kesip sorular sorabilirsiniz. Anlamadığınız bir yer. Buyurun hocam.
Mister, what you talk about is, the way I understand is a psychological approach. Am I correct?
say it again.
Psychological approach. For example, you are not limited with the network. Okay, there is many ways, and you can choose one. Basically, you're saying is let the kid learn the way they can learn.
Right, but I'm also saying, yeah, I agree, but I'm also saying, what does this mean for us as teachers to do? I cannot present any task and say, okay, learn the way you want. The way I design my task, that's what I'm trying to communicate. The way I design my task or modify a task from the textbook, because sometimes it is in the textbook, but it's not very good. I can modify it. So I'm also talking about our role as educators to present this type of task, to get to the approach that you're talking about. Yes. Welcome to all those who. Thank you. I'm really happy to see you here.
Sizi burada görmekten çok mutluyum. Hoş geldiniz.
All right. So another point about the level, high-level task. If we want students to develop the capacity to think, reason, and problem solve, then we need to start with high-level cognitive complex tasks. Right? You cannot give the children all the time just like really low-level, back to basic tasks and expect them all of a sudden to become problem solvers. We need to engage them, right? That's why it's very important the task that we engage them on. And we need to start from the very beginning, engaging children with high-level tasks. Okay. So, in that first part, I just like made the case for thinking, for us as educators, for thinking about the task that we are using with our kids, and always think about what level of thinking this requires our students to engage. And as we noticed, right, sometimes we think that the same mathematical concept, but it generates different output from the kids, depending on the type of attack. So that's why my first part was like, please, whenever you're teaching mathematics, at the elementary or at any level, think very well and reflect on the task that you are presenting. Make sure that it does engage them in higher level thinking.
You're right, you.
Okay. Let's move to another aspect, which is like using stories as context for mathematizing. So as you notice in the
Hikaye kullanımı matematik problemlerinde önemli bir yer kapsayabilir.
So as you notice in the first few tasks that I shared with you, there was no context. There was like some mathematical facts and then some questions. Now I'm gonna see like why that's not enough. We need also to include a story context. Okay, now I'm presenting you with a task, and the question is, what do you notice or what do you wonder? This is really a nice routine also at the elementary grade. We use it now we're using it a lot with students. You give them something, and then you ask them for what do they notice, and some questions that they have about what they notice. So if I give you this, what do you notice? I mean, if you take like...
Eğer bunu verdiğimde size diyor neyi fark ediyorsunuz? Mesela ne fark ettiniz? Farklılık nedir burada? Are you waiting for answer?
Yes, if you want.
Evet, tabii cevap vermek istiyorsalar fark ettiklerini
You have to
söyleyin.
volunteer. If you notice anything interesting in this...
Burada değişik bir şey gördünüz mü? Farklı bir şey gördünüz mü?
Yes?
Hepsi 15 de.
All the total plus is 50. Is it true?
Yes?
Doğruymuş.
Absolutely right. I mean, if
Kesinlikle doğru.
you spend more time, you notice that if you do the sum this way, or this way, or even diagonally, you always get the answer 15.
Evet, hepsini topladığınızda satır satır 15 ettiğini göreceksiniz.
And in recreational math, this is called the magic square. And there's a lot of work, even like from history of mathematics, on the magic square. And when you give it to children,
Bir magic square. How can I translate? Sihirli kare.
alright, so I presented this task, and you do agree that this task is higher level than if I just give you a worksheet with the math facts, right? 6 plus 1 plus 8 equals... If I give the children the magic square, it's a higher level because there's more problem solving. Right? Do we agree with this?
Ya, bu fikre katılıyor musunuz diyor, böyle bir işte magic square, yani sihirli kare çocukların gelişimine fayda sağlar.
Evet.
Okay.
Daha fazla dikkat ölçüyor hocam.
He agreed your idea. Is notice that we look it here.
Great. So, but I'm saying also that this is maybe not enough. Maybe we can even make it, add another layer and make it more relevant and interesting to kids. And what if we use storytelling content? What if this magic square is not something just that the teacher presents, but it's also available in a story? I'm reading and then, oh, there's magic square in that story.
Şimdi bunu diyor bir hikayeleştirme yaparsak çocukların daha da çok ilgisini çekecek. Yazar gibi işte her iki nesneyi dikkatle inceledikten sonra adam şöyle konuştu. İşte Hattat'ın geride bıraktığı bu ilginç sayı karesine sihirli kare dedi. Şimdi bir kare alalım, onu 4'e bölelim. 9 ve 16 eşit kutuya bölelim. Bu kutuların her birine sayı koyun gibi hikayeleştirirseniz diyor, bu daha da dikkat çekecektir.
And actually, this excerpt is taken from a book called The Man Who Counted. It's available in Turkish and it's called, I don't know, Sihirli Mathematik.
Benzer şekilde disiplinler arası ilişkide de hikaye anlatımı önemli. Kimse işte sihirli karenin kökenini bilmiyor ve böyle bir hikaye yazdığımızda daha da dikkat çekici hale geçecektir diye yazda örnek vermiş.
And when you read about the magic square in that book, you'll see also how there are opportunities to engage in some interdisciplinary connection. Already, like in this excerpt, I can do maybe some history connection, literacy because I'm doing reading.
Ya burada diyor işte tarihle de bir bağlantımız var, edebiyatla da bir bağlantımız var. Yani farklı disiplinlerin aslında ilişkilerle birbiriyle bağlantıları var. Bunu gösterme açısından da önemli.
Maybe geography.
Maybe geography, belki de coğrafyayla da bağlantısı var tabii ki. I agree your idea is a geography. Okay.
Also, mathematically, when you have this literature context, it gives you a way for more advanced explorations. For example, in this book, after they talk about the magic square, you're reading, and then they present another square.
Kitabı okuyorsunuz, sonra sayfasını çeviriyorsunuz, diğer başka bir büyülü kareye geçiyor.
Take a minute and see what's same and what's different between those
Ya
two.
bu iki tanesinin arasındaki aynı ya da farklı şeyin ne olduğunu görebilen var mı?
Şeyi toplayınca.
hocam.
Aynı
Soldaki-
kitap toplayınca aynı değeri veriyor. 4 oluyor.
Please speak up. Who's talking?
Who's
Yes.
talking? I will translate it. Ali Can.
Katları topladığımız zaman 34 sayısını veriyor. Yani yan
The gives of the total 34. 34
Uh-huh.
is it true?
So this is like, yes, all of them. So it is a magic square. And this time the sum is not 15, it's 34.
44.
Good job, absolutely. So this is something
Tebrikler,
similar.
çok iyi iş çıkardın.
What are some of the differences?
Peki farklılıklar nedir? Yani ne gibi farklılıklar da var? Hı.
Soldaki 3 basamak, diğeri 4 basamak.
Okay. For example, when the left side is 3 parts, others 4 parts, for example. Is there a difference?
Yani sonuçları da farklı çıkıyor. Ama
Is the-
sonuçları yani sonuçları veriyor.
Is the result was different, but when the totals same.
Okay, so that is this idea.
Is a good idea. Yani iyi fikir.
If we had also more time and we're doing math exploration, you will notice this one that if you take any four, look here, if you take this square, 4, 5, 11, and 14, you're gonna get 34. If you get 5, 16, 11, and 2, you're gonna get 34. If you get this 4, there are 86 ways to get 34 in this magic.
Ya burada diyor 34 diyor bu büyünün özelliği, yani büyülü karenin içinde 34'ü bulmanız.
And this story, right, the story context will help you to figure this out. And even in mathematics, sometimes they call it diabolical or pan-diagonal square.
It's written here. I can translate it for you.
Yeah.
diğer özelliği sağlıklı toplarına
Right? It's fascinating, really. I mean, it's a square, but at the same time, it has a lot of characteristics and features. This is another example
Başka bir örnek vermek istiyorum.
of using story also to present some mathematical problem solving. This is for
Bir hikaye kullanmak ve hikaye kullanırken bunu sunmak görüyorsunuz
this
şekildeki.
is for lower grade.
Biraz yüksek, lower grade, yani yüksek seviyede. Lower grade, düşük seviyede pardon. Lower grade ya,
Yeah.
not higher grade. Okay.
And right, I mean, when you read, you see like here when you have those questions. Let's see what trickery she and when that there will be like in the rest of the book a lot of math problems for the kids to do.
Burada birçok matematik problemi var yapılması gereken.
So, storytelling is very powerful way to make the mathematics lesson more meaningful.
Yani hikaye anlatma tekniği diyor, matematikte çok güçlü bir yöntemdir.
We do have research really is showing that when a story was used to teach mathematical concept,
Yani hikaye kullandığımızda matematik açısından gelişimi kaydederiz.
understanding of the concept enhanced and student success levels were increased. I'm moving now to the second point, and you can follow here. Sorry. Stories also have proven useful in reducing mathematical misconception. Also, there's a lot of research that is showing that. And this result can be interpreted by the fact that children's stories can change students from being passive to becoming active participants. I'm moving now to the third point. Children's stories can promote a high level of interaction between students and teachers that regular lessons and activities would not otherwise achieve. And I'm gonna end with the last paragraph. When children listen to stories, they create mental images that belong to them. And
Son
that
paragrafa baktığımızda da şunu görürüz. Yani çocuklar hikayeleri dinlediklerinde kendine ait zihinsel imgeler yaratırlar. Böylece öğretilirken kavramı ve kişisel olarak önemli olan bir şeyi bağlarlar. I read.
Yes, no, that's great. And the way we are advocating for the use of stories, it's not just for motivation. right? We want to use them, what we call rich context for mathematizing. And notice that here I didn't say mathematics, I said mathematizing. So it's no more, for me now, it's not no more a word, it's like really a verb.
Fiile dönüştü.
Yani evet, eyleme dönüştürme açısından önemlidir. Yoruldum artık da çevirmek. It's very difficult to translate in Turkish and in English it's very... Is there anybody help me is here? Okay, please.
Mr. First, I want to be sure that
Yes,
I
sure,
understand right.
Mhm.
Mr. What you're trying to say is turn something into mathematical, but in a fun way, for to children understand easily the complex numeric things. Am I right?
Yes.
Anladığım şey hocam şu, matematikteki belli karmaşık olayları çocuğun anlayabilmesi için mathematizing dedi. Yani matematikleştirmeye çalışalım.
Evet.
Faraza diyelim ki bir yaşta armutlar var. Her birini 1 yapalım, 2 yapalım, 3 yapalım. Çocuğa da toplatalım. Sonra bunları kasaya koyalım gibi. Bu benim örneğimdi. Yani hocamın demek istediği sanırım şu. Çocuğun anlayacağı dile çevir. Hikayeleştirme.
Storytelling.
So, yeah, I mean, just also right, I mean the idea that when you turn it into a verb, it's something that you have to do. There's a lot of action, right? As opposed as I'm reading about math or I'm learning about math, when we say mathematizing, there's action. I'm doing the math, right? I'm thinking, I'm drawing, I'm comparing, I'm relating. There's all of like mental action.
Karşılaştırma yapıyor, bağlantı kuruyor ve bunlar arasında çıkarımlar elde ediyor. Bu da önemli bir işlev görüyor.
So that's how we want to use the stories, not just as motivation, as real context from where we invite the children to do mathematics activities. Okay. Now the third part is all right. We will be using stories, but is there any benefit to use stories from history of mathematics?
Ve hikayeler kullanabiliriz ama diyor bunun ne faydası vardır? Yani ne gibi faydası vardır?
And you can read this quote here. Highlighting stories similar to those of our students allow them to develop their own mathematical identities. Question.
Soru.
Did you know that Ibn Haytham worked on magic square puzzles?
İbn Haydam'ın puzzle'ını biliyor musunuz? Büyülü karesinin puzzle'ını.
If you didn't know, raise your hand. If you didn't know before, raise your hand.
Bilmiyorsanız parmak kaldırabilirsiniz.
Okay.
Ben de bilmiyorum. Aynen diyorum.
Yeah, me too. I mean, before this project, I didn't know that. So, would you be interested in learning more about how Ibn Haytham worked on magic square puzzle?
Yes.
Yes.
This looks like Sudoku.
Yes, that is like the puzzle, the game aspect of it. Yeah. Oh, I should have projected this one. Okay. Now, did you know that Ibn Haytham used visual proofs and visual ways to prove difficult mathematical concepts? If you didn't know, raise your hand.
İbn Haydam karışık matematik problemlerini gerçekleştirmiş ve kanıtlamıştır yıllar önce.
Right. And it's really interesting because now in math education they talk all the time about visual representation, use always like diagrams, and this guy 1,000 years before, he was doing exactly that.
Yunus help to you, okay.
Time, how are we doing with time? Just
Zamanımız var mı? Okay, we have time.
we have till 2.
So,
All right, let's see. I'm gonna play just really few seconds from a video about Ibn Haytham,
İbn Haytam'la ilgili bir video göstereceğim şimdi.
and then come back to see how we can use some activities in math.
What's the matter, Leila?
It's nothing, Granddad. Just sort of worried about the science class tomorrow. I have to give a demonstration.
That sounds like fun. Fun.
I have to explain how we see, and I want to have these diagrams, which I don't understand. I'm going to fail. I'm going to get laughed at by everyone.
Ah, the quest of every true scientist. Sometimes it takes more than a few diagrams to truly understand our world. Now, let's see what we have here.
So when we tried this before, you will have the Turkish translation. Now it's not showing. That's okay.
İngilizce attılar. Belki İngilizce çalışır.
Hocam, coğrafya hocası mı?
Yeah. 1,000 years before your birth, a great civilization spread across the earth. At its center, the grand city of Baghdad did rise, ruled by Khalifa Ma'mun the Wise. In his desire for peace, the Khalif believed that through acquiring knowledge, prosperity could be achieved. Thus forth, he began his epic quest to collect the world's knowledge from east to west. Ancient books from Greece, Egypt, and Persia were collected. Wisdom from China, Africa, and India into Arabic translated. From around the globe came many women and men of different faiths and cultures in harmony then. Across the land, they built houses of wisdom and excellence, inspiring 1,001 inventions and clinics. For hundreds of years, working together, they learned and spread what would help change the world forever.
Caliph Farah, we see because light rays reflect off objects and their image enters our eyes.
Dear boy, nonsense. The great Greek scholar Euclid has taught that invisible rays shine out of our eyes, and that is how we see.
But I have here a manuscript from the Greek scholar Aristotle.
Young Ibn al-Haytham, choose your sources more wisely.
Great debates, grand theories, but where is the proof?
My friend from Basra, your way to the truth will be hard. Have faith.
But,
Debate, logic, not enough to become a true scientist.
Behold! Behold, those seekers of the truth, behold! To the best minds of this land, I have come from the illustrious city of Cairo with a message from our ruler, Al-Hakim bi Amrillah. Our beloved Egypt is threatened by a mighty force of nature, the great River Nile. When it floods, it destroys and devastates our land. Our ruler has heard that here, in this gathering, there is a man who believes he has a monumental solution to this epic challenge: to build a giant dam across the Nile. Let this fearless scholar step forth, make himself known, and embark upon this historic task of heroic proportions.
it is I, Al-Hasan ibn al-Haytham. Yes, I believe a dam can be built. I humbly accept this mission.
Beware, my friend, beware. This is surely a
Just because of the time, I'll stop here. So Ibn Haytham goes to Egypt, and he thought that he would be able to solve the problem of the of the Nile, but he couldn't do it. So he will be in prison, and for actually quite some time, for a few years. And that's where he, his theory about the vision and how do we see, that's where it gets elaborated. And he writes really a couple of books about vision and optics in the prison. This, until now, right, I mean, this is like really redefined the way the optics field continued. And the film at the end, like, ends with like a conversation between the grandfather and Layla, and he tells her that whenever you use the camera, let's try to remember like where this came from and the scientists who struggled to get there. And the power of this video is that it shows that scientists fail, right? I mean, he didn't get it from the first time. It's okay to fail, and like with perseverance and like more work and more thinking, you can get like to like very high. And this is something that we want even in problem solving, mathematical problem solving. Okay, let me get back to yes. All right. Do you remember our friend QB? So
Küpleri hatırlıyor musunuz?
in that story,
Bu hikaye.
it was like about using the die, and by using the die, the book presents a method. If you draw a die and you get 6, do you know what will be the number on the bottom?
Küp yaparken mesela köşelerini.
1, right? So right when it lands on 6,
Mesela
here,
6.
the one on the bottom will be 1. If
Altta 1 kalır mesela. Yani altta
5 will be 2.
5, 2.
3 will be 4.
Yani 3.
So all with the sum is 7, right? And the book leads the children to use this as a strategy.
Böylece çocuklar bir strateji kullanırlar.
They give them this problem here about a birthday.
Yani bir mesela doğum gününde.
When you are 6, how many like
mesela 6 yaşında kaç tane mum kullanmamız gerekir?
And using Cube's way, now we know that like 1 plus 6 is 7, 2 plus 5 is 7, 3 plus 4 is 7, and the answer is like 3, 7, which is 21. Now can we use Ibn Haytham's way, which is like visual? So, right, I mean now children know about Ibn Haytham, we have this like QB problem, and I was like, okay, can you show what the answer from 1 to 6? And through like a exploration, curricular exploration, they can get to the idea that those of you who teach elementary, these are called the Cousinet rod, and they are like really model for the from 1 to 10, but we're using from 1 to 6, and you see like if we double, you see here what happens, 1 plus 2 plus 3 plus 4 plus 5 plus 6. If I double that, what do I get? I get this rectangle, which is 6 by 7, 6 by 7, and remember I started by doubling, so I need to divide by 2, and that's how I get my answer 21. So this is the same answer, the same even like method, but drawn visually using Ibn al-Haytham's method. The book also, you can do like further investigation. You can move from the 6 to the 20, and then later to the 100. When we use the 100, we can go back to history of math and talk the story of Karl Gauss, who it said when he was elementary student, he did use this like cubist method. Okay, so why would we add this layer of history and storytelling to mathematics? Using history of mathematics in teaching, it helps really communicate three very strong, big ideas. The first one is, I'm reading now this one. Can you read it? Yeah, I will read
Bir
it in
insan
English.
etkinliği olarak matematik insanların matematiğin evriminde yer aldığı, matematik çok kültürlüdür ve matematiğin tarih boyunca birçok farklı kültür aracıyla geliştiği ve iki yönlü etkisi vardır. Bu kültürlerin matematiğin şekillenmesi üzerinde bir etkisi olmuştur ve bunun tersi de doğrudur. Okay, thank you.
And again, I go with the same line. Stories that are used from history can be an example of culturally responsive pedagogy artifact. Because I'm reading the second paragraph, historical stories
İkinci
become
paragrafı okuyorum.
mirror stories as opposed to window stories, as they reflect images of our students' multiple identities. Okay, so taking all the three themes, tasks, the importance of high-level tasks, using storytelling in teaching mathematics, and using examples from history because of this culturally responsive. Taking all that together is the ground for my research that I'm doing currently actually in Turkey, and the title is Mathematics Teachers Using Stories from History of Mathematics, Intersection of Elementary Math with Storytelling, Identity and History in the Islamic Context. This is a collaboration with Dr. Burcu Durmaz from Süleyman Demirel University in Sparta. And some of the examples that I presented before are taken from this work, like those, when I asked you about Ibn al-Haytham, this is taken from this research. We are trying to answer those research questions. How can elementary teachers use historical stories of mathematicians and or mathematical artifacts to help elementary students learn math? How can elementary teachers use storytelling and history math to present students in the Islamic context example that speak to their identity? And how can culturally responsive lessons based on historical stories in the Islamic context affect student mathematical identity and mindset? So we're collecting those stories, but let me just speak about the collection of stories. There are three really characteristics that we are trying to abide with. The first one is historical. We want our examples to be really factual, so we are really reading and we want our examples to be factual, not exaggerated, glorified, nor like minimized or underestimated. The second dilemma is developmental when we're looking for stories, because we're dealing with elementary kids, right? I mean, in history of mathematics, there's a lot of beautiful stories, but young kids will not understand. It's like for higher grade. So always like we want to make sure that the story that we pick can be used with elementary kids. And curricular, we always want to make sure that the story that we have has a curricular potential, and we can align it with like the Turkish curriculum and in my case also the standards in the US. Little bit, just.
It's very difficult to translate. Yardımcı olacak biri var mı? Beynim durdu artık çeviriyorum.
Hocam tarihi olarak abartmayın ya da ne bileyim yani şanlılaştırmayın. Fakat minimize de etmeyin de normal sıradan bir anlatın diyor. Developmental dediği gelişimsel açıdan baktığımızda çocuklara göre hikaye seçmek lazım diyor. Curricular'da herhalde burada müfredata uygun şekilde pratik aynen ona göre çalışın.
Okay, thank you. And we came up so far with 10 stories from history of math. Here they are in Turkish. So El-Kendi, 2 stories from Ibn al-Haytham, Arada Usturlab, El-Kashi and Pi, Talib bin Qurra, Umar Khayyam, Hasib Tabari, Ibn Laban, and El-Uqaydis. So we have so far been working on 10 examples. We did do a tool to see if children are interested with this, and those tools we gave to school children, to see if they are interested in what story. So we asked this, right, for the kids, and we also, after we did the tool with the kids, we did also focus groups. So we spoke to kids from grades 2 to 6. Okay, I'm gonna skip the numeric. And we do have sort of ranking, initial ranking, in terms of interest. Kids in grade 2, they are more interested in this stories from out of the 10. Third grade, they are interested in those. Fourth grade, they are interested in this story. So now we have a picture of, in terms of the interest of kids. We did, as I said before, we did want to know more about the student voice. So we did talk to them, and it was really beautiful. We videotaped those stories, and then we analyzed this. We asked them questions about mathematics in general. We asked them also to reflect on that selection tool, and there were some questions based on the culturally responsive. Okay.
Could you finish? Is it possible?
Yes. This is like. Alright. When we ask Turkish kids about mathematicians from their own culture, they really didn't.
Türk çocuklarına sorduk bizim kültür.
Younger kids, they didn't know anyone. They didn't say anyone.
Genç çocuklar bir şey söylemedi yani.
Older kids, they named only few, mainly like Avicenna and Ali Koshu. And mainly they mentioned Western inventors like Bell and Edison. For us, this confirms really the need to expose kids about who mathematicians are and what do they do. So when you ask the child,
Matematikçiler ne yapmışlar diye sorduk.
and also the importance of having more stories from the Islamic context.
Bunların da birçok İslami hikayelerle bir ilişkili içinde olduğunu görmekteyiz.
But there's one nuance that I really want. It was like a reminder for us. One of the children said, when we use their invention or have fun with their invention, I feel close to them. So, which means it's not enough just to get a story from the Islamic context and so it will become relevant. No, we need also to show the relevance and to their daily life today.
Ya ya öğrencilere sormuşlar işte neden bilmiyorsunuz falan. Bildiğimiz böyle onların icatlarını kullandığımız zaman onlara daha yakın hissediyoruz, onları daha iyi biliyoruz. Fakat hiçbir şeyini kullanmadığımız, ne bileyim formülü falan kullanmadığımız zaman da bilmiyoruz, bize de yakın gelmiyor gibi bir şey.
And I want to end with this also from a child. If you can read this sentence, because in a way our work is to make this possible. That's what we want, those materials to make this possible. He said, I see their work, I read it from the internet, they have done it, I can do it too. I give myself determination to do better. And this is a beautiful quote from a child here in Turkey, and it's inspiring because that's what we are trying to do with our project. And thank you.
Teşekkürler. Thank you very much for your speech and thank you very much for visiting. Sayın Bakanımızı plaketini vermek üzere çağırıyoruz.